Corey and I pulled together this talk. We've gone through some renditions of this talk with various groups. And I just want to thank the Watershed Council for giving us the opportunity to present this new learning that we have kind of developed over the last year or so. And really, it's fundamental to a lot of questions that I've been hearing from folks in the community is it working? And so that has been on the precipice of the work we've been doing. A lot of at SRSC and even at NOAA and at the state is making sure the actions for salmon recovery are working towards salmon recovery. And this project here, even though it's Corey and myself presenting it as two of the co-PIs, Joe Anderson is also a co-PI on this project with Washington State Fish and Wildlife. And what we're going to be talking about is basically the responses of Chinook salmon to estuary restoration. And a culmination, a little bit of the intensely monitored Watershed program, which is the IMW, and the inclusion of other studies that look at things more regionally to try to detect some of these trends over time that John was talking about. And the way it's going to go is I'm going to do kind of the first part. I'm going to focus a little bit more on the Skagit, and then Corey's going to take a little bit more of a regional look. And again, when I just said Corey, myself, and Joe, one thing that we've also heard in a lot of these science series conversations and what I've heard in the community is, oh, it's just SRSC, or it's just the state, or it's just NOAA. Actually, with all this work, we are constantly working with regional colleagues that have been part of this program from tribal entities, tribal governments, federal, state, academic scientists have reviewed a portion or sometimes all of the work that we're presenting today. So it really is an army who is learning about these systems and trying to understand how Chinook are responding. And more locally, the funding to help support this is the intensely monitored Watershed project or program of the RCO office, some ESRP funding from WDFW, long-term smolt trap monitoring that we need to keep going in Burlington. And then the tribes have been allocating part of their PST research dollars to this for, I think, about 25 years. And I want to take a moment and just highlight that part right there was really Lorraine Loomis's idea, where I had a conversation with Eric. So Eric's getting nostalgic. He's in retirement. He's telling me stories. And so part of the IMW was her vision in the estuary to try to understand change. Like, okay, we're going to be making these changes. I want to know what's happening. I want to know what's going on out there. And that was the marching orders Eric received. So anyway, I just want to highlight it's been a big group to present the result, and we are just fortunate enough to be the ones talking about it, but there's a lot of folks that have their hands in this. So to start out with, we all know Chinook are important. We generally like Chinook. They're very tasty. We like fishing for them. They're an important economic driver in the basin, and they're absolutely vital cultural and subsistence resource for the tribal nations in this area. We also, most of us here know that they are ESA listed as threatened, and we are working very hard to try to recover them. We have a 2005 authorized in 7 recovery plan that sets out some actions to try to recover the species. And specifically in Puget Sound, we have 21 spawning populations, and we're going to be focusing on a handful here as representatives of what could be happening across the Puget Sound. But we want to talk about that. You know, we talk about acreage a lot in the Skagit Estuary, but Skagit Estuary is just one place, a part of the whole story, which we've seen substantial estuary loss across Puget Sound. PSNRP estimates is 45 to 99% of estuaries being lost. And what we've known, not just us here in Puget Sound, but the Canadians say the same thing, folks up in Alaska say the same thing, that Chinook rear in estuaries and need estuaries to rear in. And so the importance of this loss likely is leading to demographic population implications for Chinook, and it's been identified as a limiting factor both in the Puget Sound Recovery Plan and in our local chapter, and actually most chapters within, I don't know all of them, so I'm just saying most, but I think it's all of them, have estuaries as limiting factors for Chinook recovery. Go forward. So to recover them, the big we, have been trying to invest dollars and effort Puget Sound wide to restore estuarine habitat to promote productivity of the Puget Sound Chinook salmon ESU. So with that hectares of restoration that's plotted on that graph, that's obviously resources that could be expended somewhere else. So we are interested, are Chinook salmon populations responding to this estuarine effort, this estuarine restoration effort? I want to highlight again, that graph is Puget Sound wide, not the Skagit. So it's not having any confusion about acreages. Go. So our talk is kind of composed of two components. One component is the Skagit IMW, focused within the Skagit system, where we were trying to understand how restoration influences juvenile fish response, so the juvenile outmigrants, and specifically ideas of habitat capacity, because there was habitat loss in the Skagit, how habitat is used by juvenile fish, and if there's any shifts in the life histories that the fish exhibit. Correigh is going to talk a little bit more about population benefits. One thing that we kind of get at in the way we monitor Skagit is Skagit gives us kind of an observation of one. So it's nice to look at other systems as well, bring them together so we can say, oh, across 4 or 5 or 6 populations, we're seeing comparable responses when estuary restoration happens. It's what we do as a science. It's called trying to get degrees of freedom. So this is where it gets important, where we need to know something about the critter that we're trying to investigate. And the important thing is we all learn about the salmon life cycle. The eggs get deposited in the river, they grow up as alevins, pop on out migrate as smolts, go out to the ocean and come back. But many salmon actually have different pathways in which they can choose to go down to complete that life cycle. And with Chinook, I would say, one of the foundational things in the Skagit Recovery Plan was to dig into this and to understand the different pathways juvenile fish exhibit within the Skagit system. And this is building off of observations taken in Healy et al., I believe, 1980, and others that build off the stream and ocean type. And what we saw through some initial research investigation is if fish move out, they can either choose to rear, be that stream type and stay in the system, or become ocean type. So they move out of the system, and then they can come into the delta. And in the delta, they can migrate through very quickly and just head on out, or they can rear in the delta. And what we saw in the ocean survival estimates is that those fish that rear in the delta grow quickly and tend to survive to adulthood more than those that just pass through. So as we built this, we looked at specifically in the Skagit and trying to link the IMW study design questions. We wanted to link them very quickly, and I was probably in grad school when this was being done. But with Eric and Corey and Joe, was trying to link very closely the recovery actions with the study design approach to this so we could evaluate them one-to-one. And the recovery plan in the Skagit specifically said reduction in capacity. We knew we lost 80% of the estuarine habitat from historical conditions within the Skagit, and the system was made to be more simple. It had less branching, less distributaries. So what we lost was the amount of habitat and the amount of connectivity. And what was postulated is that we would be getting some kind of population bottlenecking, where we have a bunch of fish leaving the river system and then limited rearing and connectivity within the system that then bottleneck the population moving forward. So that was kind of some of the idea of the recovery plan, and what we are evaluating within IMW is this idea: how does restoration increasing capacity alleviate some of these stresses, if you will, in the estuary, and how we can alter connectivity on the landscape to improve how fish move through the system. In the IMW study plan, there, or I should say in the recovery plan, lots of plans here, but in the recovery plan, the general number of 2,700 acres was put into Appendix D of the recovery plan, is a number that I think lots of us talk about within the Watershed Council and broadly in the community in Skagit, this 2,700 acres. That 2,700 acres is actually based off of very specific site locations. And if you move those around, then that acreage also moves around a little bit too. But anyway, we had a list of sites where we had planned restoration. And the idea is if we do those sites, then we would meet the objectives of the recovery plan and then make it closer to our goal. Currently today, we've estimated about 660 acres of restoration has occurred. That's just one estimate. There are other estimates out there, but it is less than the 2,700. So we have more to do, and it's quite a bit less. And then in the original IMW plan, the thought was by now we would have 1,300 acres. And I want you to keep that in context because we thought the effect size would have been 1,300 acres. Also, I want to let you know that we have about 410 acres planned, Island Unit being one of them. Milltown is happening this year. Got a head nod from Jenny. So that's some other acreage. We have Smokehouse. So we have things happening right now. And part of what we do at SRC is we monitor the restoration effectiveness of each site, and the IMW is meant to scale it up across the Delta. And so looking forward, there's going to be a little bit, I'm going to talk about McGlen Jetty and what's going on there and how that is actually going to give us some inference about the connectivity. But we do want to say overall, the pace of restoration has been less than what was expected in the IMW design originally. That isn't a critique, that's just a matter of fact. And so when you see our results, I want you to take that our restoration is that effect that we're measuring, and it's not quite where we're hoping it to be. In addition, restoration is only one action happening on the landscape. Is what we call an anthropogenic gain. It's something where we're gaining salmon habitat through a human-caused action of restoration. There are also other things that are happening on the landscape, which are anthropogenic losses, human-caused losses in habitat, and then natural gains and losses. So far that I understand, salmon can't differentiate which is which. So if we were to take habitat gains and losses and put it in the context of what salmon see, it's the total net, the net gain of natural gains and losses and anthropogenic gains and losses. And through a lot of mapping and digitization work over the years, we've mapped out what the gains and losses are. One of my staff, Dr. Greg Hood, has gone out on the bayfront with the RTK GPS to map out those gains and losses, plus with aerial photography, mapping those out. And from there, we can build these graphics to show what the net change in rearing habitat for Chinook salmon is. And some look really good. And I want to point out South Fork. So the South Fork Delta area, the yellow polygon up top, we can see a marked gain and then a slight reduction because we have some natural losses kind of occurring from year to year. The bayfront, we have some gains, but actually you might be going down to a negative due to the fact that we have subsidence, storm erosion on front of the bayfront, and having losses outweighing the gains in that area. So it's a little bit of a mixed picture, but one other thing I want you to focus in on is South Fork has the most gains, and then North Fork here has some, but not as much. How we evaluate kind of full system responses is we look at the number of fish coming into the Delta. We monitor the amount of fish in the Delta through my staff were out there today going out doing fyke netting, beach seining, and looking at counting fish within the Delta. Fun fact, as of today, they have to count the Chinook. They've also counted 1.7 million three-spine sticklebacks. So, um, and so let's break these down really quick. So in-river migrant fry, these are the fish leaving the river as fry coming into the delta. As we highlighted before, fry want to rear in the delta. That's good for them. That's where they're going to gain the size and have that higher survival. And what we have here is the density, the cumulative fry density plateaus off as we get higher abundances. This shows us that there's some capacity limitation in the system. Conversely, within the sub-yearling migrants, so this is just at the smolt trap, and the adult returns, we see that also when we get more of these, we don't necessarily get more adults. And I'm going to rehash this with some nice pictures, is that in the delta, we are seeing capacity limitations. The tank is filling up. Fish are spilling over. They're going into the near shore or just going out the ocean and having low survival. This is giving us evidence of this population bottlenecking that's happening in the estuary. And so this curve here, the density dependence that we're seeing in the estuary is driving 80% of the variation in adult returns. So that means it's driving a large contribution of the population dynamics of Skagit Chinook. Another thing just to highlight is that through the IMW overall, even though this wasn't a major driver of the IMW, we tried to leverage some of the information we were learning. And one thing was like, what projects are working and what projects aren't? And so we're working on updating this. And most of you probably have seen this figure, but we can see here that dike breach, dike setback, and fill removal projects, once completed, look a lot more like a reference site than a tide gate maintenance replacement, or be it a traditional flap gate or self-regulating tide gate. I've been asked many, many times, well, doesn't the new fish-friendly tide gates, aren't they better? And my general statement is, yes, you get double the amount of fish. Instead of one, you get two, but it's not anywhere near reference condition. And we have information based in number of locations, even some on tribal reservation smokehouse, highlighting that the self-regulating tide gates do not work very well at being fish friendly. Most of the projects, we do see fish use them right away because in the Skagit, we have a lot of fish leaving the river. We have a lot of freshwater productivity. It's very different than like the Stilly, Nisqually, or Dungeness, where you don't have as much freshwater productivity coming out of the system. And I also want to highlight that we're working with others, with restoration practitioners on a continuous basis to understand how other techniques that might be put onto the landscape could be supportive of salmon recovery, or at least not inhibit salmon recovery. So this has been a lot of really great work. This analysis was done by Stu Munch at NOAA, and he is just a fantastic analyst of data. But let's start breaking this down. On the left side is the raw data. On the right side is a predictive model. So let's stick to the left side here associated with the raw data. We broke the data into two components. You remember when I showed you that the South Fork had a rapid increase in habitat, even with natural losses and anthropogenic losses? And I pointed out North Fork didn't have as much increase in habitat. So we have a North-South Fork comparison. And that's what we lay out here. And so the first blocks, 1993 to 2000, very little, basically no restoration had occurred at that time. And we can see that the North Fork and South Fork look very similar to one another. Looking at a time period of 2001 to 2009, we see a little bit of habitat restoration. Those triangles are the South Fork and the squares are the North Fork. And the South Fork has a little edge on habitat, and they look like they might be separating, but still kind of close. But in 2010 to 2021, we have a lot more habitat. We have an increase in the net primary habitat in the South Fork, and we start seeing that separation, the densities. That means the South Fork is becoming less dense. If you remember back to that tank that I showed you with all the fish packed in there and they're flopping out, when we add more habitat, we're making that tank bigger. The fish are less dense within that tank. And so here we're starting to see that with the raw data. Now, in our modeling space, we put this all together and we see that restoration is actually reducing densities at low to moderate outmigration abundance. So when we get low to moderate outmigration years, we actually have lower densities in the delta. So restoration is having a signal on that capacity within the delta. So this is a positive effect. Of course, we still remember that 660 acres and the plan was 2,700 acres. We're not seeing it at the higher abundances because, well, we need to have more likely to do. We wanted to look at the life history types. So like I said before, we have fry that come. We want them to stay in the delta because that's where it looks like they grow and rear. But those fish that just pass on through the delta and go to the near shore and out to the bay tend to not rear as well or grow as well. And so this is a comparison between the number of fish, proportion of the fish within the near shore versus the river, which is basically the delta. And we see that the number or the values are fairly similar, and they start becoming more divergent, which means that we're seeing at lower abundances or at lower outmigration levels, we're seeing fewer fish getting shot out to the near shore. They're staying in the delta, which let's just go back to Friday night. You want to go out to dinner and you didn't get out early. You're like right there at 5:30. How many people have had to walk down the street to the second restaurant because the first one was third, fourth? That's what the Chinook are doing. They went to their first restaurant, which was the Delta. It was full. They continue on. But now there's more seats at the restaurant and they're rearing longer or they're eating. So the first few slides are focused primarily on capacity. Here, we're going to talk about a little bit more connectivity. There's been a structure that most of you know about that's been there for the last century. I think 1918 is what we've settled on when it was built, but it was probably a progressive build. And it's the McGlynn jetty system that protects Swimmers Channel from sedimentation was its main goal. And so what's been through some evaluation of how we can maybe modify or change this jetty, we're finding out that it leaks and it's very leaky. It's just a pile of rocks kind of thrown up there. And we have about an estimate about 500 CFS goes through the structure. And wherever water goes, fish go. And what we're seeing is a number of individuals dying, getting strained out within the structure. And basically every day that we do a survey through the outmigration period, we're seeing salmon. Now, dead salmon on the structure. Now, I do want to take a moment and say that in the recovery plan, the McGlynn jetty and the causeway was identified as a recovery action to allow improved connectivity or allow fish, instead of having to swim around the jetty or try to find little holes to go through it, to kind of port a way for them to go up into Swin Channel or up to the North Skagit Bay to be able to rear. Now we found an additional problem, which is actually directly killing ESA listed Chinook. And not just them, we've seen starry flounder of decent size wedged in the rocks, shiner perch, number of fish. So we're working, Devin couldn't be here, Devin Smith, who usually attends these meetings, couldn't be here today because he's talking to the Army Corps on site right now. So we're having continuing meetings with them. And the idea is to try to have some fixes to improve connectivity and also reduce the direct mortality. And so there's some potential restoration benefit that we're looking at, and also potentially opening up portions of the dike that may increase connectivity. And this idea is that we might be able to improve the access to Swin Channel, which we also know is kind of underutilized by fish. but this is kind of the ongoing IMW question that we haven't answered. So before I told you there's two components, capacity and connectivity. We still haven't had a good experiment on the connectivity, but we are now hopeful something's going to happen here in which we'll be able to evaluate how changes in connectivity influence it. Cumulative estuary restoration is seeming to, on the capacity side, is seeming to have a positive effect on our on Chinook use in the estuary. It's seeming to reduce densities and is seeming to shift that life history type away from those fry migrants to ones that rear in the estuary where we know is important. And so we're seeing this increased capacity and this reduced spillover, basically. And then ultimately, what we're fighting for right now is to continue the IMW program so that we can evaluate this last big structure. And honestly, Puget Sound wide, there's probably many cases of aging infrastructure that this could provide a model of like what the potential impacts could be. So we're hoping that the surfboard will continue with the IMW program to support that. Anyway, with that, sorry, Corey, if I took too long. I pass it to Corey.
Sorry for the backlighting and maybe some airplane noise. But in any case, I'm going to talk about the next stage. So Mike did a good job of summarizing sort of the benefits of estuary restoration on juveniles, but the question often comes up once we talk about these positive effects, but how does it benefit adult returns? And so as shown by the little diagram here, it's a bit of an unfair question. I mean, you've got a number of things going on, right? So during their outmigration, juvenile salmon encounter variable conditions in both freshwater and much variability in the marine waters of Puget Sound and the ocean. And those secondary conditions are not watershed specific. Also, restoration is a management action, and just one of many that are taking and can have an effect at different life stages. There's no silver bullet to salmon recovery, and so teasing out the effect of estuary restoration is tricky given not only the variation naturally, but also the multiple management actions we're doing. Nevertheless, through ESRP funding, we decided to take this question on directly. And we needed to do this in the context of multiple watersheds, not just the Skagit River watershed. All these different watersheds you see here in this map as yellow dots. These restoration projects collectively are many natural experiments to bolster the few that we have in the Skagit. Significant numbers, 8 to 10, but still relatively small number compared to sort of the possible number that we could examine using this entire data set. Also, by focusing the analysis on smolt to adult return rates, basically counting for the fish that move downriver and sort of eliminate those river conditions to some extent. And then furthermore, by looking at multiple populations within Puget Sound, we can take account of the shared effects of marine survival that are common through all these different populations and use that shared effect to statistically control for this major source of variation without delving into the possible causes. All right, so that's the goal, and we need data for that. The specific hypotheses we're addressing here are, first, populations that are dominated by fry migrants. Those fish that move quickly through the estuary have lower productivity. The idea here is that those small fish, whether they rear in the delta or they rear in marine waters, are at much higher risk of mortality than larger fish. And so we should expect lower productivity of those populations that are dominated by a fry. The second hypothesis is pretty much the most straightforward one of our list. It's that restoration should increase the amount of estuary wetlands and channels used by Chinook salmon. And then in combination with these two responses and some of those patterns you saw demonstrated by Mike, we should expect a positive response in these smolt to adult return rates, our measured productivity of the populations, at some point post-restoration as wetland functions accumulate. And then finally, we wanted to address the shared effect. We expect that there are multiple region-wide determinants of smolt adult return rates, and these are probably difficult to simultaneously observe. And so we just identify that as a shared effect. And so next slide, you can put this into a statistical function. Basically, those smolt adult return rates are some function of that shared trend. That's the shared marine survival across populations. The wetland habitat change, and in a particular population, and you see that little subscript there. That's sort of some T with a lag, right? Some lagged effect. Maybe it's a zero lag. Maybe the benefits accrue immediately, and so that question mark there you see would be zero in that case. But in some time in the future, those wetland habitat benefits would accrue, and therefore you get a positive response due to restoration. But you need sizable restoration as well. So it's the amount of wetland habitat lagged some period of time. We'd also expect to see that effect of migrant fry, that first hypothesis up above. And then we also put in this possible interaction, thinking maybe that those populations with higher migrant fry and higher restoration would do better or worse. So that's the way we approach it. We basically have these hypotheses, we put it in terms of the statistics, and now we test this model. And so we need data to do that. The data we have are basically for each of these populations labeled here. We need wetland time series demonstrating the change in the wetland habitat as a function of restoration. As well, we need the total out migrants sampled at screw traps, and that actually limits the number of places we can do that, particularly in the Skokomish, where they have just a couple years of out migrant trapping, and so not well overlapping with the major restoration projects that have gone on in the Skokomish. And then finally, we need our smolt to adult return rate time series, and this was based on a recent report from WDFW. By Pete Lisi and Joe Anderson. They put together all the time series with collaborations across Puget Sound and standardized them using some common metrics. And so now we have a really good understanding of the natural origin smolt to adult return rates. So so as Mike showed earlier, we need that wetland time series. And this is specific to the Skagit, but we needed to put this together for all systems. And this was actually a major effort to bring all the systems in a standardized way up to snuff to look at wetland trends across Puget Sound. And so we have a couple metrics here, which I want to go over and give you a sense of what they entailed. So the simplest metric, which is below and shown in each of those graphs in yellow, is just the change in the footprint. And so that's like the existing area, and that's shown in the dark blue for this example, which is Wiley Slough. And then you add on the wetland footprint for each restoration, and over time you get a step function as shown down below. And so for some places like the Elwha River, there was one big event or sort of a shared event with dam removal, and so that made this big change. Nisqually, there were a couple smaller restorations and then one very large restoration, and that creates that huge step function for the Nisqually. But for this, we wanted to get a better sense of the change in the area actually used by fish. So the footprint has all the wetlands that are adjacent to the channels. And so we came up with a couple metrics. The one we ended up using was what we call prime mirroring length. That is the length of blind channels in the system. And also the edge habitat in distributary channels. And so you can see that in shown for Wiley Slough and its vicinity. In dark blue is again the existing habitat, and then the blind channel habitat was added on in that polygon. And so it's much less than the overall footprint in terms of area. It's but we put it in terms of length just because length was a little more sensitive. And as you can see up above, it responds a little more dynamically to change than footprint. There are some adjustments in the systems as time goes on. So in Wiley Slough, for example, there was a bunch of habitat initially that was created via impoundments, and those impoundments started filling up, and so the channel length, that primary length, would change similarly. And so you can see, if you compare the top and bottom, several differences. For the Skokomish, for example, there was a change from a blind channel to a major distributary, and that actually sort of reduced the amount just by switching the bins from one to another. That's why you see the decrease, and so forth. So you can get increases and decreases with primarying length, and it's a little more sensitive to temporal change. So that's the metric we used for delta wetland trends across Puget Sound. And so then we put that all together. And so next slide just gives you some of the sense of the methods for how to do this. But basically, we need 2 time periods to get a sense of the natural trend. And then that trend also helps us sort of extrapolate before those time periods and after the time periods where we made the explicit measurements. And then we add in the restoration polygons to get the sort of total amount of not only natural change, but restoration change as well. And that natural change is pretty small for most systems. The 2 big differences are in the LWA, where there was that the dam removal created a huge amount of change within the delta of the LWA, and also in the Skagit, where the North Fork avulsion had a major effect on wetland habitat. Okay, so we put all this together, we put it in our model, and we looked at many different models. And basically, the model that popped out was a combination of a number of factors. And the factors I'm going to focus on are the sort of that effect of migrant fry, and the effect of restoration. And so that's the next slide. So what we see here, this is a complicated graph, so let me walk you through it. First, on the y-axis, the vertical axis is our dependent measure of productivity. That's the smolt to-adult return rate, and here we factor out that shared effect across systems. And so this is like a system-specific measure of marine survival. And it's also got this log transformation, and that basically is done to compress the axis and make it more amenable for doing statistics. But to keep in mind that the actual effects would be stretched out. On the x-axis, we have the primary length measure. That's the amount of habitat change in each year. And an important point here is there's a lag effect. And so that lag is 7 years. And so that's keep that in mind. And so basically this is this effect was the best effect we had, we determined, but there's a variety of other lags we looked at, and there's only we can only look at lags so long before we run out of data in on the fish. That's the x-axis. Now each point you see there is a population year combination, and so what this is doing is tracking as a wetland habitat gets added. It's basically each of those points represents the change from the wetland habitat for a particular population. And so those points are described not only by their colors and shapes, but by their size. And their size in this case represents the proportion of fry measured in river. And so those with lower proportion of fry have a smaller circle, and those with more fry have a larger symbol. And one immediate sort of finding is that first hypothesis was supported. Those small circles you see right at the top are indicating that those lower the populations with lower numbers of fry had much higher survival than those dominated by fry, which are at the bottom. And the Skagit, in this case, which are the teal squares, is one example of a population dominated by fry. But the big finding we have is this positive effect of the change in rearing length. And that was a strongly supported result, indicating that across populations, when you have a large restoration project, you have a benefit on adult returns. But you got to be patient for it. That benefit accrues 7 years after that large restoration project. Could be longer, it could be a little shorter, but our data is limited to that time, and I'll get back to that point in a second. But so this is a pretty important finding. It really puts the work that Skagit Watershed Council, Skagit River System Cooperative, and many other collaborators to put estuary restoration projects in place across Puget Sound. That is basically, this analysis supports the idea that those restoration projects are having positive benefits. This sort of highlights the importance for us to be a bit patient when we think about wanting to see results from these projects. As you know, restoration takes time, 10 to 20 years for all the planning, community support, purchase of land, and construction of these projects. And then in addition to that, there's this wait, that development of ecosystem function within these restored areas that appears, based on the statistical analysis, to be at least 7 years. And so we got to keep that in mind as we're moving forward with these restoration projects, and with the idea that we need to provide some benefit or document these benefits of estuary restoration. These accrual of benefits is highlighted by this review I have here, showing that there's multiple habitat elements within estuaries that contribute to population benefits. And so I've given us a couple here, and these cartoons are based on real data to show the long-term sort of change when we see sort of conditions flatten out, indicating that habitat element has recovered. And so some examples here are wetland and channel reconnection. That can be pretty quick based on a restoration project, but the changes in the geometry of channels may take a while, particularly if a project is underbuilt. And so that may take over 40 years, depending upon the ability of that project to conform to natural processes. Likewise, the estuary restoration projects have some time course for the recovery of vegetation, whether it's estuarine emergent vegetation or woody plants. And within those channels that we see, there's some recovery of the invertebrate community and other fishes that are using those. And all these different habitat elements have particular functions for fish. That planform geometry, for example, is really important for refuge habitat for juvenile Chinook salmon. The estuarine emergent marsh and woody plants are really important as cover and as shade, keeping the areas cool. And then the recovery of the fish and prey communities are really important from perspective of growth benefits for Chinook. So with the IMW project, which Mike talked about, next slide, really focuses on that first one, right? Just sort of the overall effect of reconnection, and doesn't really address these longer term benefits. And that's what that second study did. And when you, next slide, when you look at that second study, we're go to the next slide. Yeah, you're really talking about this really short time frame here. That bar that you see here of increasing benefit as time goes on. And what appears to be the case, if all this were true, would be that as time goes on and these more and more, and these functions more and more are accrued, we should be even seeing better effects long term. And so we've got a very short time frame based on our statistics to evaluate this, but we can expect, based on what we know about how these areas change, that benefit would accrue. There's one caveat to that, of course, and that's that if things stayed the same and these wetland areas maintained their function. But we know that with effects of climate change, particularly sea level rise and rising temperatures, that's not necessarily the case. And I mean, it's important that within the Skagit, at least, that Skagit habitat trends analysis really demonstrated that you do have some of these changes for the worse as well as for the better. And so in those maps, you see the red areas, particularly along the bayfront, and in the South Fork as well, where there's definitely been habitat loss. Some of that, such as in the South Fork, can be attributed to recovery of overbuilt habitat, as say areas fill into more natural channels. But a lot of this is wetland habitat loss along the bayfront due to erosion and sea level rise. And that's really demonstrated. That purple graphic on the to the left there, you can see that despite one restoration project, which increased amount of habitat, generally speaking, we're having a decrease. So it's important to note that this is sort of a dynamic kind of thing that we want to be paying attention to when we're thinking about multiple restoration projects and how much we need to do in the Skagit. I've used all these restoration, and so has Mike, the idea of these are experiments to demonstrate a population effect. But in addition, all this restoration efforts is a huge social experiment and really demonstrates two sort of important things we need to be cognizant as a society. First, the spirit of volunteerism, whether that's shared interest in salmon recovery, willing landowners, and protecting human life and property. That volunteerism really will drive the ability for us to get new restoration projects on the ground. And then the spirit of patience, being willing to invest 10 to 20 years in not only the project planning and implementation, but also seeing the benefits. And just to summarize the takeaways from this presentation, not only with Mike's, but also with mine, we have essentially that restoration, the work that we do in the Skagit IMW links restoration science with recovery objectives, addresses the effectiveness of estuary restoration at both project and population scales. As we showed, restoration projects are making a big difference, both in terms of juvenile productivity, but also for adults. And then these big projects are certainly a challenging social experiment, and that will continue and maybe be exacerbated as climate change increases its impacts. Nevertheless, observing benefits of restoration is a long-term endeavor that we are hoping to address not only by continued IMW funds, but also a continued effort in monitoring throughout Puget Sound. And as we move forward, we want to be cognizant of the fact that additional restoration may be needed to address these climate impacts. And with that, I'd be happy to take questions as well as Mike, I assume.
Yes.
I think, your first slide, I think, showed the 4 different pathways, different time and price. And is that, would they all, if there was enough room, would all the different populations that maximize their time to delta, or is any of that characteristic of the population? And some tend to spend a little more time to delta, others tend to go further up. Or is it all allowed in that greater population characteristic also that 20?
Most, what it looks like for the Skagit is most of the bottlenecking is happening in the estuary. According to that, the adult return rates seem to be strongly associated with the densities in the estuary, right? With that capping. That's our best available science now. We have talked about, and there's publications, it's in the recovery plan, Zimmerman et al. 2015 have talked about floodplain limitations as well, which also has that demographic effect. Would we expect all the fish to absolutely change 100% their life history type, their pathway? No. There is some Correigh did his PhD in behavioral science, so like in like the behavior decision. So maybe he'll correct me on this one, but there is some kind of choice with that and pre-existing conditions that the fish then chooses to go out. So even if it's perfect, we'll still have some fry migrants. We're just trying to reduce that proportion. The other flip side is that the hope is once if we achieve our recovery objectives, hope is we're at carrying capacity again, because then we're still habitat limited, but we're at our goals. And that's where we just want to be, is we're at our recovery goals. So the hope would be then that we're not doing anything that would limit that capacity of the habitat, but it's just more of we've just met our goal. We got our adult returns where we want them. We're starting to talk as co-managers with our federal friends to potentially have some leniency in the regulations so that we can do what we need to do. But yeah.
So I got a question for you. So on your restaurant analogy, I'm going to extend it a little. Oh, I have it already. So on your restaurant. Okay, is it working? Okay, on your restaurant analogy, is it fair to, I'm going to extend it a little bit in the context of your first choice is your really nice restaurant that you really want to go to. And then the second choice is, well, I kind of want to go there. Third choice is, well, it's okay. Fourth choice, I really don't want to be there, but that's where I'm going to eat because the food isn't really that great. I mean, in certain sense, isn't that what's happening? I mean, they want the Delta is really good. That's my restaurant of choice. I get out in the marine side. I'm not finding a really equivalent for Delta, right? So you're moving and you're going to worse and sort of feeding her.
Worse and worse. And if you wanted to even complicate it more, you could say then the pocket estuaries is that random, really amazing food truck that you just stumble upon.
Stumble on.
Yeah, yeah.
No, that's
If you want to continue with that analogy.
No, I like it. That's even better. I like that.
But yeah,
So that's why they matter. Right.
I mean, that's what they're telling us because we're seeing with their growth and survival that it decreases the less rearing they have, either in the freshwater estuary or even in the near shore.
Okay.
So extending that analogy, is there a way to improve those other restaurants too? Right, like simultaneously?
Yeah, so I think that's what we're trying to get at with the lag effect is that, restoration, again, horrible with analogies is like surgery, right? And it takes a while to recover from that. So after you're out there with the backhoe and you get process right, you kind of set it on its structure, the site needs time to develop after that. You could have complications such as non-native vegetation, invasive vegetation, that then you need to do that management and those type of things. So there's ways in which you might need to then improve the native vegetation for prey fallout. I'm going to stop there and give it to Correigh because I know Correigh's thought a lot more about the food webs.
Yeah, also what I mean, we're doing a lot of learning with estuary restoration, and so we might conceivably be able to speed up that recovery time if we built the right projects so that they were in line with the habitat processes. And we have learned substantial amounts over the last 10, 20 years as these restoration projects have evolved over time. Those places which are subsided are clearly at sort of a challenging place, and so recovering them is really a matter of increasing their not only sort of the amount of habitat but their elevation as well. And so if we can sort of jumpstart some of these restoration, maybe we can improve that time lag and make these really productive habitats on a shorter timeline.
And just to go back, Yuki, we're still trying to get structure and process right. And I think we're actually going to a pretty positive place. Like we've had some recent projects that need to revisit with structure and process. And I hope once we kind of nail down structure and process is kind of the foundation, that's the stage, right? We can start then looking more into other things that we know are important, like food webs, We know food webs are important. I mean, I know in floodplain work, we need to do a lot more work on how do we influence food webs in floodplains to feed fish. And there's a lot of papers on that, and that's kind of the next horizon. And I can see that for estuaries.
So one of the questions I had is you have the Skykomish and the Snoqualmie on there as IMW, but neither of them actually reach tidal influence. So it's the Snohomish that has the estuary. So are you using the Snohomish as the surrogate for the populations in the sky and the snow? And then how do you differentiate? I mean, is that smolt trap data specifically identifying sky and snow fish? Is that what's?
Yeah. So the population data is based on sky or Snoqualmie. So basically, those are out migrants and adult returns to those two different systems. But you're right that the estuary wetland change is Snohomish specific for both of them.
So Corey, this is one for you. On the SAR and the SARS, are you willing to speculate to what, sort of roughly the percentage it's improved for the Skagit, given your analysis?
So yes, we can speculate that a little bit. The challenge, of course,
Yeah.
is there's a couple of challenges. So
Okay.
first, there's the effect of sort of variables we do control, such as harvest management. That's sort of a dynamically determined measure. That's every year, and so we factor it in. But there are uncertainties to that estimation, and so the data we use factor in terminal harvest, but not sort of commercial harvest broadly. And so there's going to be some noise to that signal, right?
Right.
Secondarily, so we have this shared effect across populations, which is complex.
Yeah.
And so any measure of sort of like what's the benefit Skagit specific is you got to factor that in one way or the other, and so it's sort of hard to say with that shared effect. But we're looking at probably like a 40% increase resulting from restoration from pre-restoration levels.
Okay, now if Corey says that, you can take that to the bank pretty much. He's a cautious. No, I got one. So one other quick question then on SARS and your slide about the various restoration components and the leg.
Yeah.
And where then you put in the gray bar sort of showing that 7-year leg. Yeah. Then I would sort of interpret what you said there is that then this improvement in SAR is pretty conservative estimate since we're only in the early part because of that leg. You see what I'm saying? We're not okay. All right. So it's 40% plus.
So the longest lag we could look at was 9 years. And that then we start losing much of the smolt to adult return rate data if we look at longer lags than 9 years. And so it's entirely possible that we get higher levels, but we're just not as well able to detect it at longer time.
So again, you're asking about the response, and I just want to say kudos to the NOAA scientists, because remember the recovery plan is 2,700 acres. Our MW was planned for 1,300 acres is what the scientists at the time thought they needed to measure effect. We have 660 with natural losses that are happening on the landscape. So it's been amazing that we see trends like this. And I think to elucidate some of the more nuanced questions you might have, we need island unit, we need Milltown, we need smokehouse to get that bigger effect, because you're given what are really great biometricians a chance to actually measure more than this. So as it's really, really small, it's harder to measure.
660 out of, 2,700 acres. I think many of us understand that's kind of an arbitrary number. It's really the carrying capacity that we're looking for. And 660 acres, do you have a Chinook smolt carrying capacity associated with those? Because my understanding was projects like Wiley were provided a capacity that was much greater. And so is that why you're seeing like less than 40% acreage providing 40% greater survival? Or am I linking things that shouldn't be linked? And there's probably lots of questions. Sorry.
Oh boy. Okay, Jenny. So first, the 660 is almost, I think almost all those projects were identified in the recovery plan. So it is actually apples to apples there. But you're correct. As soon as we start adding projects outside the recovery plan, then it gets a little messy. As any plan lives over time, it becomes less specific, right? So I know there are some thoughts about updating it, which maybe is not a bad idea. The other part of that is on the smolt capacity. We do track that in habitat status and trends with the Wiley sloop because we are actually mapping that habitat loss. So there's a big capacity estimate for all the subsided land and the impoundments that were provided, and that does exist out there. And we've tracked the natural losses because it was in a way overbuilt. Impoundments are not, ponds are not a common habitat feature in a delta in this area. And so those filled in with sediment, they're shrinking. So that's part of the natural losses that would be that we are accounting for.
So you have a 40% greater survival, smolt to an adult. Sorry.
Yeah.
But you're not at 40% of your habitat goal. 660 is not 40% of 2,700.
Yeah, I wouldn't equate those.
Yeah, I think you're trying to put 80 foot.
Yeah, so at this point in time, like, again, our porthole into this world, into the fish's world is really small because the restoration effect size is small. As we have bigger effect size, generally our observation, correct me if you disagree, Corey, our ability to observe the world becomes better, greater, and then we can get into the nuance. I wouldn't really highlight that 40%. The thing is that restoration's working. Let's just stop right there. Restoration
Yeah.
working.
Yeah, I think the important point is that the that analysis is based on multiple populations, right? And so this is a population response across systems. And so it's got some of the Skagit signal in it, but you want to keep in mind that the Skagit's got its own trajectory as well. And so thinking about specific goals I agree with Mike. Concentrate on the overall result. Restoration is beneficial, as opposed to restoration is this X amount beneficial in the Skagit. That we're still learning about.
So the follow-up question then, Corey, to that is, well, I'm going to make one comment. One, everybody, if anybody asks you, IMWs are essential, critical, and they got to continue. Okay. Then two, and what other data would you like to have, or what other kind of, I'm going to get to pit tags maybe. What other kind of data information do you need so that we even get better data information for the Skagit? And what we should be asking for that would even improve your ability to assess impact and effect.
Go first, Corey. I'm curious of your answer.
Well, so I guess I feel like there's weaknesses to the analysis as well that you could throw stones at in some sense, and maybe so I pointed out a couple of the uncertainties when calculating smolt to return rates. There's other elements though, like, I mean, what we're doing is we're postulating sort of a series of logical sort of hypotheses to come up with this idea that estuary restoration benefits adults. So basically, fish are using these systems, they're getting a benefit out of these systems in terms of growth or survival, and that's reflected when they move into marine waters and grow, right? And so I would like there to be more information, for example, about making sure those the sort of assumptions we're putting in here are true. Better understanding, for example, of what the growth benefits are under different, say, abundances, so that we can definitely that we can clearly demonstrate that when you're residing in here, you're getting a restoration signal in growth, and B, that that effect is alleviated via restoration, the density dependent effect. That's one take. I think there's a lot of work that could be done with the actual sort of smolt without return data to get a better estimate of that, and that's always something that we can quibble with. But I mean, given that we've seen the signal with the data set that we have, it's really encouraging.
So I know that all salmon use the estuary differently, but as you are collecting your monitoring data, are you collecting enough information about what are now kind of incidental fish that if there were to be additional listings or the desire to analyze for a different species, that you would be able to use the data you've been collected to analyze for those?
Absolutely. So we not only count and ID every single fish that we come across in our catch. We measure the lengths, which gives us an inference about size and growth and that kind of thing, of 20 fish for each species. So we get a subsample across that. And that's just kudos to the program that I walked into this. This is Eric, Correigh, and others that developed this program. So, and it's funny, the Skagit IMW was kind of a Skagit Chinook program in the 90s, but before that, it started out as a coho program. So as Eric, again, in his nostalgia, telling us about, yeah, first we were worried about coho in the early 90s, and that's how this has all started. So we do collect chum. We get great, actually, information on chum. Species that are a little bit more problematic, I think Omicus, rainbow steelhead, are a little problematic because we just don't catch them very well. And maybe some sea run cutthroat. But, you know, we catch enough to help out with a study for a genetic analysis of cutthroat in the Skagit. So we collected some fin clips there. But yes, absolutely. So we've kind of alluded to something. So I'd like to, my last comment, I'd like to just convert something. And too bad Brendan's going to have to catch him later because he's the main person I'm trying to tell this is. We've kind of highlighted that, like, if the IMW continues, we are aware that the surfboard is looking to potentially start seeing the sunset of the IMWs. It's a little unclear, but there's some plans to make some possibilities being considered by a surfboard next week. So I'm going to give testimony next week that the Skagit IMW continues until we maybe have this recent large amount of capacity add to the system and more specifically evaluate the connectivity questions that were originally proposed that the surfboard wanted and signed off on, and making sure that they just stick with it and with us, because we're going to get there and we're going to learn a lot. As you just saw, we are. So anyway, we're working on that. And then the other one right now, it seems like for future studies, I'm not really thinking that. I'm just trying to hold on to the ones that we have right now. So with that, I'll just say thank you for giving us some time. Appreciate sharing what we're seeing and what we're learning. And the door is always open for questions, email, what have you.
Yeah, thank you very much. And please contact me if you have any questions on the work that we've been doing.
Thanks very much.
Also, if you do get a chance, the Army Corps keeps telling us that the changing the jetty needs an act of Congress. So if you think that's an important project,
Okay.
there's some people you can send a letter to them.
Right. But Corey, that reminds me when I had to deal with Columbia issues, it was everybody in the Army Corps says no until you can get to the general. General is the only person that can say yes. So maybe we got to get up higher in the food chain. I think you're absolutely right. So thanks again to Corey and Mike. I mean, this is like really key information. And just so one other thing, and Corey can correct me if I get it wrong, or Mike will too. But so smolt to adult returns. I mean, another way to think about it is that for every 100 fish, every 100 juveniles that go out, and I'm not saying it's equivalent to, but just every 100 juveniles go out, we used to get 1 adult back. Now, roughly, for every 100 that go out, we get 1.4 back. Okay, so I mean, that's, or you can change it the other way. Every 140 that go out, you get 2. So that's the idea. We're getting better return on our investment. And it's complicated to attribute it to any one thing because small tool adult is basically the whole life cycle, and there are all those things in there. So I could talk about this and get into this forever because this is like so cool.